So welcome to today's deep dive. We are exploring the oscillating universe theory today, and our mission for you is to answer a pretty mind-bending question. Was the Big Bang actually the beginning of time, or, was it just a cosmic reboot?
Well, to understand why physicists are even asking that in the first place, we really have to look at how that divide by zero error creates this massive dead end.
Right.
Because tracking the Hubble expansion backward inevitably leads us to a singularity.
Which is just mathematically impossible to describe.
Exactly.
Yeah.
That fundamental flaw in the classic model is what birthed this alternative concept. The idea that the Big Bang wasn't an absolute beginning at all, it was just like a transition phase from a previous cycle.
I mean, if it is not the absolute beginning, we're assuming there was a before. Which, honestly, that completely breaks our linear understanding of how time itself started.
It really does force a total perspective shift. So instead of a one-off Genesis event, the cosmos undergoes these endless cycles. Like right now we are in an expansion phase.
Right, galaxies moving apart, temperatures dropping, all that.
Yeah, but if we account for the universe's entropy and mass, the geometry of space-time suggests this expansion doesn't just go on forever.
Oh, really?
Yeah, eventually the universe hits a maximum limit, it stops expanding, and it begins a contraction phase.
Wow, so it starts collapsing back in on itself.
Exactly, returning to a state of just unimaginable, ultra-high density.
Oh, yeah, hold on. Let me challenge that for a second. If all that matter and energy collapses inward, following gravity backward into this infinitely dense point, doesn't that violent crush just lead us right back to the exact same singularity problem?
You would definitely think so, yeah.
I mean, a contraction doesn't really seem to solve the whole divide by zero dead end at all.
Well, that assumes gravity behaves identically at all scales, but quantum mechanics kind of alters the playing field here. What is fascinating is how quantum gravity kicks in at the absolute extreme.
Okay, how so?
Think of space-time not as an infinitely compressible void, but as a physical mesh with a fundamental limit, which we call the Planck length.
Okay, I'm with you.
When a contracting universe forces all its matter down to that microscopic grid, it physically cannot be squeezed any tighter.
Oh, okay, let's unpack this. Because the energy has literally nowhere else to go, that inward gravitational pull hits a physical floor and just snaps outward.
Yes, it essentially turns gravity into a massive repulsive spring. The rules invert.
That is wild.
At that microscopic density, quantum gravity acts as a buffer.
So it prevents the universe from just collapsing into infinite nothingness.
Right, the universe reaches a limit and violently bounces back.
Wait, so if I were somehow standing inside the universe during this transition, I wouldn't perceive, like, a graceful bouncing pivot?
No, definitely not.
I would just see a colossal, blinding explosion of outward energy. Like, I would basically see a Big Bang.
Exactly. And if we connect this to the bigger picture, it implies our local Big Bang is just one minimum point in an infinite sequence of expansions and contractions.
With each cycle stretching out over hundreds of billions, or maybe even trillions of years.
And an endless loop.
So what does this all mean for you, listening right now? I mean, if this mathematically grounded model actually holds up, it fundamentally rewrites reality.
It really does.
The universe isn't a single isolated event with a distinct start date. Time didn't just turn on like a light switch. It is the eternal ongoing engine.
An engine with no true beginning and no true end.
And here is where it gets really interesting. In this theoretical model, these massive bounces might not be perfect, clean resets.
Right, the incredible compression might actually preserve a tiny fraction of information from the previous cycle.
Like quantum echoes surviving the cosmic crush.
Exactly, yeah.
I want to leave you with this thought to explore on your own. If traces of a previous cosmic cycle really do survive that massive physical reset, could some of the strange, unexplained astronomical anomalies we observe out in the deep field today actually be fossilized scars?
That is a fascinating question.
What if we're literally looking at the surviving structures of a universe that existed long before our own?